Osteoarthritis, an age-related, low-grade inflammatory disease of the synovial joints, is one of the most costly and disabling forms of arthritis, being more prevalent than rheumatoid arthritis or other arthritic diseases, and represents a major public health burden. Osteoarthritis is characterized by the progressive deterioration of articular cartilage and structural changes to the synovial joint, including the synovium, meniscus in the knee, periarticular ligaments, adipose tissues, for example the infrapatellar fat pad in the knee, and subchondral bone. Although osteoarthritis was historically viewed as a wear and tear disease, it is now generally accepted to be a low-grade inflammatory disease, affecting the entire joint. Osteoarthritis is not a homogeneous disease, but is in fact highly heterogeneous, characterized by a number of different phenotypes, including a distinct metabolic phenotype, each of which is thought to have different drivers. The various phenotypes of osteoarthritis have important differences, but are likely to share key elements such as age, biochemical factors, and metabolic alterations. Preclinical research in animal models of osteoarthritis and clinical studies in patients with osteoarthritis have shown that age, obesity, and metabolic syndrome are major risk factors for the development of the disease. Obesity is the strongest risk factor for disease onset in the knee, and mechanical factors such as ambulatory load dominate the risk for the disease progression. However, the fact that obese individuals have an increased risk of developing osteoarthritis in non-weight bearing joints such as hands and wrists suggests that factors produced by white adipose tissue might have a role in the onset and progression of osteoarthritis. Increased adiposity and dysfunction of white adipose tissues is closely related to the chronic low-grade inflammatory status that is a systemic feature of both obesity and osteoarthritis. A consequence of this dysfunction is that white adipose tissue adopts an inflammatory profile, producing pro-inflammatory factors known as adipocones that promote inflammatory and degradation of cartilage and thus affect the whole joint microenvironment in the body. Therefore, tackling obesity and the underlying causes of metabolic syndrome through lifestyle changes such as improved diet, increased physical activity, and weight loss has been proposed as a realistic and achievable approach for preventing osteoarthritis and thus reducing its burden on society. However, a greater understanding of the important roles of biochemical factors, joint injury, obesity, and metabolic syndrome in the pathogenesis of osteoarthritis is required to reduce the effect of this disease on public health. Evidence suggests that patients with osteoarthritis fall into multiple phenotypic groups defined on the basis of the main driver of the disease, one of which is a distinct metabolic phenotype, although all osteoarthritic phenotypes involve metabolic alterations. Cartilage, bone, and synovium are all affected by external and internal drivers of the disease, such as inflammation, injury, metabolic reprogramming, and immunomodulation. But different synovial joint tissues dominate the disease in different patients with osteoarthritis. So, how does metabolism affect articular cartilage? Cartilage is a metabolically active connective tissue with a reduced access to oxygen and glucose compared with synovial fluid and plasma, producing an environment that presents its few resident cells with a number of metabolic challenges. The turnover of extracellular matrix molecules in mature skeletal cartilage is extremely slow. The half-life of type 2 collagen, the major fibrillary collagen in cartilage, is between 100 and 400 years. Thus, healthy cartilage with an optimal extracellular matrix function requires the maintenance of a delicate balance between anabolic and catabolic activities, which is critical for long-term tissue integrity and the capacity for cartilage to repair itself. In healthy joints, chondrocytes utilize glucose as well as other metabolic fuels and sources of energy. Glucose utilization through glycolysis and the oxidative phosphorylation helps to maintain an optimal level of mitochondrial function and biogenesis. The metabolism of healthy chondrocytes is therefore optimized to maintain normal energy through homeostasis via signaling through the AMP activated protein kinase to peroxisome proliferator activated receptor pathway. This pathway shown here. So in healthy cartilage, chondrocytes have the metabolic flexibility to generate energy and promote cell survival during periods of acute nutrient stress by upregulating mitochondrial respiration and reducing the rate of reactive nitrogen and oxygen species production. The metabolic adaptation of osteoarthritic articular cartilage to new environmental conditions is evident in the early stages of the disease, when attempts to repair and regenerate the cartilage matrix have an increased likelihood of success. However, cartilage from patients with osteoarthritis at a later stage of the disease do not seem to have this metabolic flexibility. Chondrocytes in osteoarthritis switch from oxidative phosphorylation to glycolysis as their main source of energy metabolism. In osteoarthritic joints, chondrocytes are exposed to pro-inflammatory cytokines and microenvironmental alterations, including hypoxia and nutrient stress. Mitochondrial metabolism is impaired and reactive oxygen species accumulate, causing damage to mitochondria, which inhibits the AMP activated protein kinase signaling and activity, as well as downregulates SIRT1 and decreases the level of peroxisome proliferator activated receptor, the master regulator of mitochondrial biogenesis. It can be seen that the effect osteoarthritis has on an individual and society as a whole can be quite detrimental to their health. Therefore, through further studies of the disease and how a healthy diet and active lifestyle can prevent it, the burden to individuals and society can be reduced, and a healthy community can be a result of this. Thank you.